In this video, we're going to take a look at how to handle binomials that contain radicals. So we're going to learn how to simplify products and quotients of binomial expressions that contain radicals. So there's not any new definitions or theorems. We are going to learn what a conjugate is. So I guess we do get one definition in here, but other than that, it's just uh, seeing how to use what we already know with how to multiply radicals and add and subtract like radicals, and we're going to combine that um, with what we know about binomials. So for this first example, we're taking 4 plus the square root of 7, which is a binomial because we have two terms being added together, and we're going to multiply that by 3 plus 2 square root of 7, so that's another binomial. So we're going to multiply these together, and to multiply them, we do the same thing we do when we multiply um, binomials that we looked at earlier when we were doing polynomials. So I need to distribute this binomial across this binomial. In other words, I have to take 4 times everything in this binomial. So it'd be 4 times 3 plus 2 square root of 7. But I also have to take the square root of 7 times this binomial. So it'll be plus square root of 7 times 3 plus 2 square root of 7. And then from here, we need to distribute. So 4 times 3 gives us 12, and then 4 times 2 gives us 8, and then we have a square root of 7 tagging along. And then the square root of 7 times 3 gives me 3 square root of 7. And then the square root of 7 times the square root of 7, well, I'm going to get 2 square root 7 squared. So let's see, we have a 12, and then if I have 8 square root of 7 plus 3 square root of 7, so those are like radicals. So I combine those to get 11 square root of 7. And then the square root of 7 squared, that's the absolute value of 7. And so we get, let's see, 12 plus 11 square root of 7. And then 2 times the absolute value of 7 is 14. 14 and 12 give us 26 plus 11 square root 7. So I can't simplify anymore because I have 26 and then 11 square root of 7, so I don't have like radicals. So I can't combine those anymore, so we just leave it at that. So let's simplify this one. I have a binomial that has two radicals in it, square roots, and it's being squared. So we'll just use the definition of exponents. So in this case, being squared, so that just says it's 2 square root of 3 minus square root of 6 times itself. So I'm going to multiply these two binomials together. So I'm going to take 2 square root of 3, and I have to multiply it by everything in this second binomial. And then I have to take the negative square root of 6, and I have to multiply it by everything in that second binomial. And then we'll distribute. So 2 times 2 gives me 4. Square root of 3 times the square root of 3 is the square root of 3 squared. And then 2 times negative 1 is negative 2. Square root of 3 times the square root of 6 is the square root of 18. And then negative square root of 6 times 2 square root of 3, I'm going to get negative 2 square root 18. Negative times the negative is positive, and then the square root of 6 times the square root of 6 is the square root of 6 squared. And let's see, the square root of 3 squared, that's the absolute value of 3. I have like radicals. Negative 2 square root of 18 minus 2 square root of 18 be negative 4 square root of 18. And then the square root of 6 squared is the absolute value of 6. So 4 times the absolute value of 3 is 12. And then the square root of 18 can simplify. That would be 3 squared, which is 9, times 2. So we get 12 Actually, we can combine like terms. 12 plus 6 is 18. And the square root of 3 squared, that's the absolute value of 3. So we end up with 18 minus 12 square root 2. And those are not like radicals, so that's as far as we can take that one. So that's as simplified as we're going to get. So we do have one definition in here. So consider the case where A, B, C, and D are real numbers. So they can be any number you can possibly think of. But let's have B and D be positive. And you'll see why here in a second. So if I take the number A times the square root of B, that's why we want B to be positive, because the square root B needs to be positive, so it's a real number. Plus C times the square root of D. So again, since D is under a square root, we want it to be positive so that we have a real number. And then what if we took those exact same numbers, A, B, C, D? So the same A is here, the same B, the same C, and the same D, but the only change we're going to make is instead of a plus C, we're going to do a minus C. So the exact same numbers except for a plus comes between them and a minus comes between them. Well, if you have that exact situation, these two binomials are called conjugates. So this binomial and this binomial are called conjugates. Now, why do we care? Well, it turns out if you multiply two conjugates together that look like this, their product will have no radicals in it whatsoever. So when you multiply two conjugates containing radicals like this, their product will have no radicals in it whatsoever, and that's going to prove handy, as we'll see here soon. So let's look at this example. I have 3 plus the square root of 5 divided by 3 minus the square root of 5. So I have a fraction, and that fraction has a square root in the denominator, which we're not allowed to have. So we have to get rid of that square root. Well, 3 minus the square root of 5 looks an awful lot like this. So um, we have 3 minus the square root of 5 is what we have. Well, if you look, that would mean we'd have 3 times the square root of 0 minus 1 square root of 5. Because 3 times the square root of, oh, be square root of 1. Let's try that again. So it'd be 3 times the square root of 1 minus 1 times the square root of 5. Because 3 times the square root of 1 is 3. And then 1 times the square root of 5 is negative square root of 5. So this is what I currently have. And I know that there's something out there called the conjugate, and when I multiply them together, I don't have any radicals. Well, we're trying to get rid of a radical. So what we're going to do is we're going to multiply by the conjugate. So we're going to rationalize the denominator, and the way we're going to do that is we're going to use the conjugate. So I'm going to multiply by 1, but I'm going to multiply by 1 in a very special way. I'm going to multiply by the conjugate, which would be 3 plus the square root of 5. Now, how did I know to do that? Because 3 minus the square root of 5 and 3 plus the square root of 5, those are conjugates. And when I multiply them together, there will be no radicals. So let's see why that happens. So the top, I'll take the top times the top. So it's going to be 3 plus the square root of 5 times 3 plus the square root of 5. And then I'm going to take the bottom times the bottom. So it'd be 3 minus square root of 5, 3 plus square root of 5. Okay, so we just practiced how to multiply these together, so let's go ahead and do that. So it'd be 3 times 3 plus square root of 5 plus square root of 5 times 3 plus square root of 5. On the bottom, same thing. So it'd be 3 times 3 plus square root of 5 minus the square root of 5 times 3 plus square root of 5. Let's see what we get. So 3 times 3 is 9. And then we get plus 3 square root 5. And then square root of 5 times 3 is another 3 square root 5. Square root of 5 times square root of 5 is the square root of 5 squared. And then in the denominator, give myself a little bit more room there. In the denominator, we're going to have 9, and then we're going to have plus 3 square root of 5, and then we'll have a negative 3 square root 5, and then a negative times a positive would be a negative square root 5 squared. So in the numerator, I have like radicals. I have 3 square root of 5 plus 3 square root of 5. So that'd be 9 plus 6 square root 5. And the square root of 5 squared, that's the absolute value of 5. In the denominator, I have like radicals. I have 3 square root of 5 minus 3 square root of 5. So that's 0. So I have 9 minus square root of 5 squared is absolute value of 5. Let's see, 9 plus 5 is 14. Plus 6 square root of 5. On the bottom, 9 minus the absolute value of 5 would be 4. Let's see, we can simplify this a little bit more. In the numerator, why don't we go ahead and take out a 2. And then that 2 and that 4 will simplify. And I got 7 plus 3 square root of 5 all divided by 2. So we took this fraction and we simplified it so that there's no square roots or radicals in the denominator. And we did that by using the conjugate. So this thing and this thing, those are conjugates. All right, one more. So let's let y, or f of x, equal x plus 1 divided by x. So we have a rational function. It's been a while since we've looked at a rational function, but here we go. We've got a rational function here, and we want to find f of the square root of 3 plus 2. So we've done this many, many times. We're just going to plug in square root of 3 plus 2 for x into the function. So f of the square root of 3 plus 2 would be square root of 3 plus 2 plus 1 divided by square root of 3 plus 2. So let's simplify. Up top we have like terms, 2 plus 1. So that would be 3 plus the square root of 3 divided by 2 plus the square root of 3. So now it looks an awful lot like the one we just did. So we're going to use the same idea. I'm going to multiply by the conjugate. So that would be 2 minus the square root of 3. Notice I wrote the radicals second. So if there's only one radical in the binomial, write the radical second. That way, when you do the conjugate, we need to make sure that the radical, one of them is positive and one of them is negative. So for the conjugate, for multiplying the conjugates together, if you don't want a radical in your answer, make sure the radical portion, one of them is positive and one of them is negative. All right, so let's multiply those together. Let's see what we get. So we're going to do 3 times 2 minus square root of 3. And then we're going to do the square root of 3 times 2 minus square root 3. In the denominator, we're going to get 2 plus 2 minus square root 3. And then square root of 3 times 2 minus square root 3. Go ahead and distribute. We'll get 6 minus 3 square root 3. So all I'm doing is distributing here. Same thing on the bottom. And And then we'll get plus 2 square root 3 minus square root of 3 squared. In the denominator, I'll get 4 minus 2 square root 3 plus 2 square root 3 minus square root of 3 squared. And yeah, that'll work. Let's go ahead and combine our like radicals. So negative 3 square root of 3 plus 2 square root of 3. I'd have negative 1 of those. In the denominator, negative 2 square root of 3 plus 2 square root of 3. That'd be 0. So 6 minus the absolute value of 3 and 4 minus the absolute value of 3. I end up with just 3 minus the square root of 3. So we plugged x into this function and it gave me back a y value. So the coordinate square root of 3 plus 2, comma, 3 minus the square root of 3 is on the graph of f of x equals x plus 1 over x. Now keep in mind, if I had you plot this point, we'd be guessing at where to plot it. So you feel free to run this through a calculator and see what a decimal would be. So this coordinate as a decimal is about 3.732. That's an approximate value. And 3 minus the square root of 3 is about 1.268. So if you actually had to plot that coordinate, you'd put a point really close to 3.732 and 1.268. So this would be the exact value of x. This is the exact value of y. These are the approximate values that would be more useful if we were actually plotting the coordinate by hand.